Welcome to WPI.edu/listen, your go-to audio news and podcasts for all things Worcester Polytechnic Institute. After you've listened in, check out our other episodes and dive deep into the exciting news stories shaping the WPI community. Thursday, September 11th, 2025. WPI entrepreneurs find pricing, awareness, and supplies impact. Rare earth recycling industry. Interviews with 130-plus industry insiders reveal demand for domestic rare earth sources. When a group of WPI students and faculty members first set out in 2022 to interview people connected to the rare earth magnet industry, they wanted to know if an innovative magnet recycling business could succeed. After more than 130 interviews, says Adam Powell, associate professor in the Department of Mechanical and Materials Engineering, and a member of the team, the group concluded that the answer is a qualified yes. We learned there is demand for recycled materials, and a lot of people want a domestic recycling industry to grow, Powell says. Yet the reality is that only a small number of U.S. companies are building recycling capacity. The industry is still maturing as companies develop facilities, awareness of recycling grows, and a steady supply of old magnets builds. Rare earth refers to a group of metallic elements such as neodymium that are abundant in the Earth's crust, but difficult and environmentally damaging to mine and process. Magnets made from rare earth minerals are used in everything from hybrid and electric vehicles to wind turbines and fighter jets, and the total market for rare earth elements was valued at more than $3 billion in 2023. China supplies most of the world's rare earth minerals, and has used its hold on the market as a political tool. In early 2025, China threatened to limit rare earth exports, especially to Western defense contractors, as a response to U.S. tariffs. During its review, the WPI group found that challenges for rare earth recycling include incentivizing the recycling of materials and competing with magnets made from virgin materials. The WPI group also found that challenges for rare earth recycling include scrap sourcing and the high cost of building recycling facilities. Those challenges could be overcome, the researchers say, by raising awareness about scrap collection, incentivizing the recycling of materials, and passing recycling-friendly legislation. Launching a profitable and sustainable recycling startup now could be difficult, says Chinenye Chinwigo, PhD class of 2023, a member of the team and a former graduate student in Powell's lab. We can continue to do research on innovative recycling technologies, but it may take several years before there is sufficient scrap at costs low enough to make recycling profitable. The WPI Group, which undertook its market research into rare earth recycling as part of a National Science Foundation I-Core project, recently published its findings in the Journal of Innovation and Entrepreneurship. In addition to Powell and Chinwigo, authors were PhD student Daniel Arthur Saher, Evan McGregor, class of 2023, MS, class of 2023, PhD student Stephen Tate, MS, class of 2021, MBA class of 2023, MS, class of 2025. Kenneth Savage, class of 2023, MS, class of 2023. MBA student, Thaddeus Zuber, class of 2022, MS, class of 2023. Benjamin Sarawagi, class of 2023, MS, class of 2024. Daniel Dietrich, class of 2022, MS, class of 2023. Emmanuel Apoku, MS, class of 2024. Rosanna Garcia, Paul R. Beswick, 57, Professor of Innovation and Entrepreneurship in the Business School. Brajendra Mishra, the Kenneth G. Merriam Professor in the Department of Mechanical and Materials Engineering, and David Smith of Newwagon Group, LLC. The WPI team enrolled in the I-Core program to assess the outlook for rare earth magnet recycling, because I-Core provides a framework for researchers and inventors to rapidly assess an invention's market potential. Technical founders often forget to understand the market needs for their inventions, says Garcia. It's important to conduct customer discovery interviews early in the innovation process, and the group took a methodical and detailed approach to this task. Chinwigo says the group was interested in examining whether a magnet recycling company could reduce material costs for magnet production, reduce dependence on foreign rare earth sources, and support corporate efforts to operate in environmentally sustainable ways. Recycling rare earth magnets involves separating magnets from electronics and extracting rare earth elements using gases, solvents, salts, or other processes. Recycled materials are currently a tiny share of the materials used in magnet manufacturing. Working with the WPI Office of Technology Innovation and Entrepreneurship, the group interviewed individuals from rare earth magnet manufacturing companies, rare earth recycling companies, national laboratories, metal alloy companies, and metal recycling companies. Those interviewed included customers, suppliers, outside experts, and government employees. They also interviewed rare earth magnet cutting companies and electronics manufacturers to assess the availability of scrap magnets for recycling. Although the team identified challenges for rare earth recycling, they also found reasons to think that the industry could grow. The people we interviewed said that recycling rare earth magnets could mitigate supply risks and appeal to companies that want to decrease their impact on the environment, says Chinwigo. As demand for rare earth elements grows, recycled materials may even become more cost-effective than new materials. Going forward, it will be important to develop business models that prioritize supply chains, costs, and environmental considerations.